Good morning, good afternoon, good evening, wherever you are. Thank you for taking time to view this video. A bit about myself. My name is Vedvyas Krishnamurthy, and I'm the head of engineering, cloud, and security practice at Zorient Corporation. Zorient is a hidden gem in the software product engineering services space with over 30 years of engineering excellence and 5,000 plus engineering professionals globally. We're based out of Sunnyvale, California, and we partner with 45 of the Fortune 100 enterprises to build, scale, and modernize mission-critical platforms, enabling them to operate smarter, faster, and more efficiently. As we all know, AI is evolving rapidly, and there's a lot to gain by leveraging AI in our day-to-day activities. Given this, we have invested in a global practice team that focuses on applying intelligence within the lifecycle of modern software platforms and products. We looked at one use case, operational efficiency, efficient product operations. Our practice developed an agentic AI cloud operations platform that promises to reduce cost and improve efficiency, thereby freeing up operational bandwidth. Today, my colleague Sanat Singhal and I are here to showcase our AI-powered multi-agent CloudOps platform that transforms how enterprises detect, triage, and remediate issues before they escalate to become critical incidents or tickets, and all of that automatically and intelligently. So let's get started. I'll hand over to my colleague Sanat, and he'll run us through the demo.
Hi everyone, I'm Sanat Singhal and I'm part of the product marketing team at Zorient. Today I'll be running you through this demo, so let's get started. What you're seeing here is a sample social networking application. Users can create profiles, follow others, and send messages. A simple but dynamic app. Behind the scenes, we use a load balancer and Nginx as gateways to the core application logic. Multiple microservices power this app, leveraging MongoDB, Postgres, Redis, and messaging systems like RabbitMQ and Kafka. Each of these adds complexity and potential failure points, all running as Kubernetes pods. Alongside the app, we've built load and chaos generators. I've started the continuous load test here, which simulates real user activity, creating users, sending messages, and generating real-world traffic. Now I'll enable the memory stress test. This triggers a pod restart, leading to API tries, latency, and 5xx API errors, all issues that would impact customers in production. We'll let that run in the background and move on to observability. So let's switch to Grafana, our observability layer. We're tracking CPU and memory usage, pod restarts, API performance, and database metrics across the entire cluster. We've set up alerts for key failure indicators, such as high response times, API error spikes, unschedulable nodes, and pod restarts. As the memory stress test runs, these metrics will spike and trigger alerts that our CloudOps AI agents will capture and triage. Now, let's look at Jaeger tracing, a tool that visualizes API requests across services. Here, you can trace the exact call path from the text service through URL shortening to deeper layers of the app. You'll see failing traces in red, showing where APIs slow down or fail entirely. These traces directly respond to the memory pressure we introduced, and they'll appear as actionable alerts in our CloudOps dashboard. Now let's open the Zorient Agentic CloudOps dashboard, the command center for your operational health. The overview gives you total alerts, triage success rate, and an AI audit score, which measures accuracy and explainability of every AI-driven action. The alert screen displays all alerts with IDs, names, severity, and confidence scores. This is where the system begins correlating and diagnosing root causes across multiple layers. Traditionally, an SRE would switch between Grafana, Jaeger, and Kubernetes logs, taking 30 to 40 minutes to diagnose a single issue. Our platform captures that same expertise in AI-readable runbooks, allowing agents to execute the same triage steps instantly and consistently. These runbooks are the foundation for repeatable, explainable automation. Let's open a runbook for debugging Nginx 500 errors. It's written in plain English describing what to check, in what order, and how to verify the findings. If engineers discover a new pattern, say a different cause of 5xx errors, they can simply add another step to the runbook. The next time the alert occurs, the AI agent automatically executes this updated logic, continuously improving its accuracy. Moving on to the setup screen, you can configure your preferred LLM model and MCP connections here. These integrate directly with Grafana, Jaeger, and future components, such as code tracking and incident management systems. The code tracking agent, for instance, performs a code MRI, scanning relevant code paths and logs to pinpoint the root cause of application-level issues. Let's say a log shows connection timeout errors. The code tracking agent identifies the affected module, inspects related code, and flags where the logic failed. Developers then receive this context automatically, enabling faster and more accurate fixes, reducing rework and mean time to resolution. Now that our fault has propagated, you'll see that 4 alerts have appeared in the system. Each alert is triaged and scored based on confidence and data quality. Most of these alerts score above 80%, meaning the AI's diagnostic confidence is high. Let's open up one of these alerts. The root cause summary shows traffic spike causing application-level memory pressure, leading to OOM kills. The AI aggregates data from Kubernetes events, application-level metrics, and API traces, forming a complete multi-layer analysis. The output is both human-readable and audit-ready. The triage journey screen illustrates how the AI orchestrator resolved the incident. It retrieved the relevant runbook, queried metrics from Grafana and Prometheus, checked for OOM events, executed Jaeger debugging, and consolidated all the findings into a verified root cause. Every action is logged for traceability and compliance. Here are the evaluation details with the scoring. Our orchestrator is built as a multi-agent system where specialized agents, observability, tracing, code, and governance collaborate dynamically. This design ensures scalability and adaptability across any enterprise cloud environment, AWS, GCP, Azure, or hybrid. Across our enterprise deployments, this architecture has reduced MTTR by up to 75%, eliminated 80% of false alerts, and improved mean time to detection, or MTTD, by 52%. The result is faster recovery, lower operational costs, and fewer sleepless nights for your SRE teams. Every AI action is explainable and traceable. The audit score ensures transparency, giving you visibility into why each action was taken. This guarantees compliance with enterprise standards and builds trust in automation at scale. With Zorion Agentic CloudOps, your infrastructure doesn't just react. It learns, adapts, and self-optimizes. From the first alert to the final fix, every step becomes faster, smarter, and more transparent. This is the future of operations: autonomous, auditable, and AI-driven. Discover how your enterprise can move from reactive firefighting to proactive intelligence. Visit Zorion.com to schedule a live demo or request a proof of value. Zorion Agentic CloudOps, where AI meets operational excellence. Thank you for watching, and we hope you enjoyed the demo.